Hi everyone, Mr. Chaffee here for our next lesson on simplifying roots. To get started, we're going to need to go over a couple of vocab terms. They should look familiar to you, but let's still review them quickly. So we've got square, which is the result of a number being multiplied by itself. Next, our square root, a number that produces a specified quantity when multiplied by itself. Then we have perfect square, which is a number whose square root is an integer. And last, our prime number, which is a number that has only one and itself as factors. So now let's go over a couple of examples and see where these terms pop up. First, we've got number 1, solve for the square root of 100. Well, 100 is a perfect square because 10 times 10 is equal to 100, so the square root of 100 is simply 10. Likewise, 81 is equal to 9 times 9, making the square root of 81 9, and 144 is equal to 12 times 12, so our square root this time we get is 12. Alright, now let's try a couple of examples where we're trying to figure out which two integers some square roots that aren't perfect squares fall between. So starting off with letter A, we have the square root of 96, which we can say 96 is in between 81 and 100 here. So the square root of 96 will be in between the square roots of 81 and 100, which we can simplify down into 9 and 10. So we can say the square root of 96 is in between 9 and 10. Let's try out letter B together. So 70 now, we can say is in between 64 and 81, making our square root of 70 in between the square roots of 64 and 81, which become 8 and 9. Why don't you pause for a moment and just do this last one by yourself, then I'll go over it together with you. So go ahead and do that now. Alright, we can say that 83 is in between 81 and 100, which again makes it the square root of 83 in between the square roots of 81 and 100, which simplify down into 9 and 10 again. And I'd just like to point out C and A, they're both in between 9 and 10, but we know that 96 is much closer to 100, so this square root is much closer to 10, and 83 is closer to 81, so this square root will be closer to 9 if we were to actually calculate their decimal values here. But let's move on to simplifying some radicals that don't have perfect squares. So letter A is asking us to find the square root of 75. In our last lesson, we went over factor trees, which are going to be useful tools again here. So let's go ahead and break 75 into its prime factorization, which will get 5, 3, and 5. And what we want to look for here, we have our square root, which is a number times itself to equal that number. So we can see we have two 5s here, which is going to give us that perfect square of 25 as a factor of 75, meaning that we can pull out that 1 5 outside of our radical sign here. And all the other remaining factors are going to be left inside of our square root sign, so we're going to end up with 5 root 3. And that's simply because if we write this another way, root 75 is the same thing as saying 25 times 3, the square root of 25 times 3, which then we simplify down into our square root of our 5 times square root of 3 here. So that's all we're doing. We're just pulling out that perfect square, that 25, which is a factor of 75 here. Let's try out another one I'll walk through together with you all. 20 will break down into its prime factorization again. We can see that we have these two 2's here, which result in the perfect square of 4 as a factor of 20. So we can immediately just pull out that perfect square and get our 2 out front and leave our 5 under our square root sign. Alright, why don't you go ahead and see if you can do these next 4 on your own. Go ahead and pause the video for a little bit and try those out, and then unpause and we'll go over them together. Alright, 72 here we've got to break down into its prime factors again. So we get 8 and 9, which becomes 4 and 2, 2 and 2, and then 9 becomes 3 and 3. So we can see we have a lot more going on this time around. We actually have 2 perfect squares that we can pull out here. So we've got our 4 right here, our 2 times 2, and our 9 is our 3 times 3. So we're going to pull out the square roots of both of these out front, which is going to give us 2 times 3, and under our square root sign, we still have our single 2 remaining. And notice we're asking for the opposite of this square root, so we still want to have that negative sign out front, which when we combine all that together, we should be getting negative 6 root 2 here. All right, 125, if we break this one down, we'll get 5 times 25, which is 5 times 5. We've got that perfect square of 25 that we can pull out. So we'll have 5 times the square root of our single 5, which remains under the square root sign. 54, notice we've got this plus or minus here, so we want to have 2 answers as a final answer here. So let's break our 54 down into 6 times 9, which becomes 2 and 3, and 3 and 3. So we have our perfect square here of 9. We can pull out that single 3 out to the front. And everything that's going to remain left over is our 2 and our 3, which multiplied together gives us 6. But like I said originally, we have our plus and minus here, so we get 2 answers this time around. We get a positive or negative 3 root 6. All right, now we've got a term already outside of our radical, but we can ignore that for now and start working on how to simplify our 242. So if we break this down, this is equivalent to 2 times 121, where 121 is a perfect square of 11 times 11. So let's pull out our 11 outside of our square root sign. So now instead of just a 9, we'll get 9 times 11 times the square root of just the 2 that remains underneath, which will become 99 root 2. All right, let's go over our checkpoints. Simplify each expression and determine if the result is a rational or irrational. So our first one we've got is the square root of 5, which we cannot simplify anymore. 5 is a prime number here, which will make this irrational. Anytime we take the square root of a prime number, we should be getting an irrational decimal there. 15 is going to be equivalent to the square roots of 3 times 5, which those don't have any perfect squares inside of them. So this is actually also going to be equal to an irrational number. And again, we can't simplify this any further because it doesn't have any square root or perfect square factors in it. We simply are left with 3 and 5 here. So we're just going to leave this one as square root of 15 again and state that it is irrational. Well, 25 is actually a perfect square. We've got 25 is equal to 5 times 5, which 5 is going to be a rational number here. 50, we've got 50 is equivalent to 5 times 10, and 10 becomes 5 and 2. We've got our perfect square of 25, so we can pull out our 5, and we'll be left with our root 2 inside. So we have our 5, which is rational, but that's being multiplied by our square root of 2, which is an irrational number. So this one is also going to be irrational. And then 100, well, 100 is a perfect square, so this one becomes 10, which is rational. All right, Jorah is buying several square rugs for her new house. The store she's purchasing them from only lists the areas, but she would also like to know the side lengths before she buys them. Given the area of each rug, determine if each side length is rational or irrational. So, since each of these rugs are squares, each of these areas, we know if we take the square root of them, we're simply going to get the perfect, or the side length of that square root. So let's go ahead and do that. I'll do these first couple here. So we've got the square root of 10. Well, 10 we know is equivalent to 2 times 5, which these are both prime and there's no more, so we can't simplify this down any further, and it's already in its prime factors, which means our square root of 10 we're going to want to just leave as is, and we're not going to be able to pull out any perfect squares. We're going to end up getting an irrational length here for this side. Okay, 18 we've got is equivalent to 6 times 3, which is 3 times 2. So we have that perfect square of our 9, 3 times 3 here. So we could say the square root of 18 is equal to 3 root 2. And again, we're going to get irrational here because we've got that root 2, which is irrational. I ran out of room, so I'm just going to write an I for irrational here. 25. Well, let's go ahead and have you pause and do these last 3 on your own and see what you can come up with for our side lengths here. All right, let's go over these 3 quick together. So if we're looking for the square root of 25, we can say we know 25 is a perfect square. We have 5 times 5 gets us 25, which makes our side length of 5, and that is a rational number. 50, well, we just did 50 in the example above. And we know 50 is the square root of 50 is going to give us 5 root 2, which we already said is irrational. We've got that square root of 2 there, going to give us an irrational number. And likewise, we did 100 a couple times earlier, so we should know the square root of 100 is 10, and 10 is a rational number here.